Very good morning to you all, and welcome to today's webinar from Dratec called Business Continuity. Today is Thursday the 18th of August, 10 o'clock, and we look forward to going through business continuity for approximately 1 hour. My name is Julian Hubble. I'm the Sales and Marketing Manager for Dratec UK, and I'm delighted to be hosting today's webinar. Also joining me today is Alex Shuker, who is our CTO, who will be available to answer any of your technical questions during the course of this webinar and also the Q&A at the end. So the agenda today is as follows. Following my introduction, I'm going to do a kind of definition to what we mean by business continuity and talk about some of the issues that lead organisations to want this type of facility. And then I'm going to cover some of the key kind of solution sets that we do. And I'm going to talk about WAN resilience, what kind of happens if a line fails and you want to do something about it. We call that WAN resilience. Secondly, what happens if a piece of hardware fails on the network and what can we do about that? This is what we term as hardware redundancy. And increasingly, another issue associated with reliability and continuity on the network is managing traffic. All sorts of bandwidth hogs these days, all sorts of maybe non-essential applications that can seriously affect the working of the network, and we're going to talk about how some tools with Dratec can assist on that side. That lends itself quite nicely into the whole managed wireless environment, where a lot of non-priority traffic can emanate from. And finally, there's a Q&A and there's also a close, which when we're going to wrap up in around about an hour's time. Okay, so let's first of all talk about the term business continuity. So business continuity, in the way we define it, is basically keeping the business connected when the network fails. And the network can fail for a whole host of reasons. First of all, you can get a line failure. Classic person outside, builders outside digging up the road. You can get ISP issues. There were some quite high profile ones recently. You can see on the right there. Even the biggest and greatest ISPs can have difficulties which can affect usability on the network. You can get hardware failure, and you can have issues with network capacity as well. The network in the office is typically very fast. The connection to broadband is typically relatively much slower. So if there's lots of things competing for that broadband connection, you can get network capacity issues. So why is this kind of important into kind of today's age? Well, lots of reasons for this, and basically it's a much greater reliance on the internet and broadband, and we see this in a whole bunch of areas. There's this migration to cloud applications. Microsoft is out in the cloud with 365. Some organizations are using Google Apps and Google Docs. There's various other applications like CRM that tend to be hosted somewhere, which requires connection to the internet to use. And there's a whole host of kind of other systems as well. Voice over IP can be provided as a cloud service, as can cloud storage. So there's lots and lots of reasons why you need constant connection to the internet for the business to operate. In some businesses, this can be even more serious. Classically, EPOS and retailers, they're doing credit card connections over the internet. They've got customers coming in. The internet's not there. They literally cannot trade. So it's a real mission critical issue if that internet connection fails. And also we've got this proliferation of remote working, whatever it may be. I'm in the office wandering around. I'm at home. I'm remote. If I can't connect, I'm in trouble. So this really all ends up, if you haven't got any internet connection, you potentially can't work, you lose sales, productivity gets very poor, potentially the phone system doesn't work, and actually you could end up with no office systems at all. So connecting to the internet and being constantly connected to the internet is an absolutely essential part of a modern business's challenges. So in terms of how we get around these types of issues, we're going to talk about three prime network failure contingencies that a Dratec solution can kind of offer. The first one is something that we call line failover or line resilience. What happens if a line fails, which can fail for a whole bunch of reasons. The second one is, what if a critical piece of hardware fails? We call this hardware redundancy. And the term we give to this within Dratec is something called high availability, or HA. And finally, what happens when all sorts of individuals, guests, visitors, whatever, start using and abusing the internet, and it starts to affect other types of traffic? Clever ways of doing that with traffic balancing control, but the general term we give to this is something called quality of service, or QoS. So let's first of all move into line resilience, and at this stage I'm going to introduce some products. So the first product I'm going to introduce, and this is the one that we're going to talk about primarily during the course of this presentation, is our flagship business class product called the Viga 2860. The 2860 is probably commonly used, our most popular product, and the reason for that is that it supports a whole bunch of interfaces. In fact, a colleague has told me that the yellow marks I put in earlier are kind of still there. So what I'm going to do, I'm just going to try and erase that. There we are, successfully done. Thank you for that, Alex. So yeah, the 2860 can connect to a multitude of interfaces. So it can connect to a VDSL service, obviously the modern BT Infinity high-speed broadband fibre connections that we're being sold all the time. The older ADSL services, both 3G and 4G, and interestingly this can do it in a number of different ways. And also Ethernet WAN as well. So Ethernet WAN can be used for Virgin Media services or satellite services, and an increasingly number of different broadband connections that are becoming available. And the final one that actually isn't perhaps talked about very much is Wi-Fi. And interestingly, believe it or not, Wi-Fi can take a very, very important part in offering you a resilient solution. So the 2860 is something we're going to be talking about primarily today. A few other things to say about this product. First of all, this was approved by BT earlier on this year. The technical term is SIN 498, or Modem Compliance Test Approved. Basically, any device that connects directly to VDSL needs to be VDSL improved in order for BT to support it. So if you haven't got an approved product, you could have difficulties in BT support. Potentially they'll charge you extra, or maybe not support you at all. The other thing to say is we're delighted to have been awarded Wireless Router of the Year with PC Pro, one of the magazines we advertise in regularly. All their subscribers were asked to vote on the best wireless router of the year, and last year, as in many years before, we won wireless router of the year. So we're delighted to have won that, and we hope to win it next year as well, or this year. Okay, so just moving on to that, a different iteration of the Viga 2860 series is a product called the Viga 2860L and LN. The L stands for LTE, and LTE really means the integration of 3G and 4G into the product. So very simply put, in addition to the standard interfaces in the product, you can plug a SIM card into the back of the router from your service provider of choice, and this offers you a fully integrated LTE 3G 4G solution. It's unlocked for any SIM card you want to put in there, and it does work with all the common providers in the UK, certainly all the big four and most of the other ones. And again, we were just awarded a great award on this, a 5-star review in IT Pro and a recommended solution for businesses. This just gives you an idea of how the whole thing kind of fits together. I'll use a better highlighter this time. So you can see here, there's a SIM card slot in the back of the router, which you can plug your SIM card into. There's a blanking plate there you can screw in just for security purposes. It does use a standard SIM card slot, but the smaller ones also work if you use the little connecting device around it. It comes with special LTE aerials, which are SMA antenna connected. We ship as standard a 1 meter cable, a little magnetic thing that you can stick on the side of a rack, and also these paddles or these aerials that you kind of connect to those. So we supply that as standard, but you can indeed buy any SME compliant aerial, and there are many ones on the market if you want to go much longer distances. Some of these are used, for example, in shopping centres where you may want to put a longer aerial in and maybe attach it to the roof somehow. Okay, so let's first of all talk about wireless WAN in terms of line resilience. So how might we use wireless WAN to get around a critical network failure? And so the example here is we've got a router attached to the internet. It's got its standard interfaces there. and denoted by the green dot there, you've got traffic going to and from the internet. A failure occurs, the line fails for some reason, and now you've got really limited options in terms of connecting to the internet. But using the wireless WAN feature, you can do some really clever things here. So one example is, I think we're all used to using mobile phones where you've got either the hotspot or the network tethering feature on it. If you've got that Wi-Fi connected, you can utilize the mobile phone in this tethering mode to make the connection to the internet and pass all your company traffic through that particular link. So obviously, the effectiveness of this will be determined by the speed of the 3G, 4G connection available. Typically, it may be less fast than the usual broadband connection available, but for mission critical traffic and keeping the business running, that actually may be all you need. And actually, it's a really good, fairly low cost and simple, effective way of getting you out of trouble. I know many of our resellers and dealers that sell Draytech products have come across situations where a customer has suddenly got a problem, and this is a really, really easy, fairly low cost way of invoking it. Another kind of variant on that is really connecting to any wireless network. In fact, a dealer rang me actually last week and said this got them out of a problem brilliantly, where they had two customers actually next to each other in the same building. Customer A lost their connection completely. Customer B had the wireless connection, and due to the cooperation of those two organisations, company B allowed them to use their Wi-Fi network and in turn their broadband service to get connected. So the dealer, the reseller, was able to get a particular customer out of trouble by piggybacking on the back of another customer that happened to be next door. So that's another really sort of neat way that you can use this particular feature. So something low cost, it comes as standard within the product, and something that's a really good way of getting you out of a problem. So that's kind of how to use the wireless WAN feature. Another and perhaps more common one is when we come to the situation of line failover. And this is basically going to be an organisation that's got two physical connections connected to the office. So in this situation here, we've got two connections. You can see here we've got a primary connection here, which is in use all the time, which is going through WAN 1. And this particular scenario, this is a VDSL high-speed service going through the VDSL modem on the router. And we have a secondary connection. In this situation, we've suggested it might be ADSL. That needs to go through a modem because the second WAN port on the Viga 2860 is an Ethernet connection, so that goes through a modem. And in normal mode, all traffic goes to the primary connection, and this secondary connection here is just purely there for backup purposes. So what basically happens is that WAN 1 line fails for some reason, and WAN 2 then picks up the load automatically. All traffic is diverted through the secondary connection, no loss of service as far as the user is concerned. And when the WAN 1 comes back again, the secondary connection will go back to the first, and everything would be as it was as normal. One of the things I'm going to be covering later in this is this whole area of managing traffic and quality of service. If you've got a high-speed primary connection and a slower speed secondary connection, you need to do some clever stuff with traffic management to ensure that the high priority applications get the best possible service on what is going to be a slower connection, but I will come to that later. So that's the first example of line failover. Primary in the main, that fails, secondary kicks in automatically. A kind of variant of this, and this is perhaps more common usage, is what we call load balancing. And in this example here, we've got two connections. Again, it's a VDSL and an ADSL, both actually being used kind of simultaneously. So traffic shares both WAN 1 and WAN 2. And actually, it's balanced in a clever way. And again, I'm going to cover something called weighted load balancing a little bit later on, so you kind of see how that works. And again, in the same way that the first example works, WAN 1 fails, all traffic is now passed down WAN 2, and effectively services is kind of resumed. Okay, so the third element I'm going to talk about in terms of line resilience is this whole area of LTE or 3G, 4G failover. And in doing that, I'm going to kind of use as an example the 2860 LTE, the L version or the LTE version of the 2860. Interestingly, for organisations that don't have this latest and greatest variant of the 2860, maybe have the older 2860 or indeed our 2830, which was the ADSL version of this, you can plug in a 3G/4G dongle into one of the USB ports, and this will effectively do the same thing, although most people agree having it integrated into the product is a much neater way of doing it. So what we're going to basically show here is that we've kind of put the SIM card into the back of the router. We've got a scenario here where the connection to the internet is happening as normal, denoted by this kind of green dot. A network failure might occur. As you can see here, there's a cross indicating that taking place. And in a similar way to WAN 2 being invoked in that line failover and load balancing scenario, in this particular example, something called WAN 3 is invoked, WAN 3 being the LTE 3G 4G connection, and all traffic will then divert down that particular connection. That will remain in place whilst the VDSL or main connection is down, and once VDSL comes back again, all traffic will then go down that primary link as if nothing has happened. So I should say in kind of doing this that this 3G 4G example here is a kind of failover mode. This also could be used potentially in a load balancing mode. We know that 4G is getting lower cost, it's getting high speed. If you kind of got it there and you're committed to a monthly contract anyway, you may as well use up the data you've bought. So again, you could use this in a clever load balancing way as well, which is quite a neat way of doing it. Okay, so that's kind of failover or balancing using 3G, 4G. So the second area that might concern business is what happens if hardware fails. Now, I mean, hardware these days is perhaps much more reliable than it was in the past. Certainly, we at Draytov have got a very, very good very good reputation for high quality products that do tend to last. Some people using them 10 years or more. So it's not a frequent occurrence, but it can occur. You know, plugs can get pulled out, you can get power surges, you can get, you know, accidental damage to devices. It can occur for a whole host of reasons. So what can we do if kind of the hardware element fails? And we've got two ways of doing this, which we call high availability. One is something called hot standby. So in hot standby mode, hopefully you can all see the diagram here. We've got the concept of two routers being used kind of simultaneously. We have a master device, and we also have a kind of slave device that's kind of used as a standby. These all go together into a switch, and obviously you can have a switch with kind of hardware redundancy built into as well that has a single connection to the ISP. So the important thing to say about hot standby is this is all about having a single connection to the internet. You've got two routers acting as the active and the second one acting as a standby, and you have a switch that shares the interfaces. The other thing about this to say is that the router configuration is synchronized between the two devices. So whatever you've got set for the master is automatically synchronized as the same configuration for the slave, because obviously if a failover does occur, they have to be configured in an absolutely identical way. Okay, so what we have is a typical scenario here where we've got, in normal mode, all traffic going through the master device, and we've got the slave on standby kind of listening to what's going on. So the master unit can have a problem, some accidental damage or something fatally has occurred. And what happens in that scenario is effectively the traffic gets automatically diverted through the slave device kind of seamlessly with no loss of service to the users, and effectively it's as if nothing had happened. Clearly when the master device is replaced or the problem is rectified, it will then move back to the master, and again you will continue in the normal way as before. So this is basically a way of mitigating against a hardware failure in what we call hot standby mode, where two devices are synchronized, one is the master and the slave takes over if the main one fails. So that's the first example, a hot standby. The second example that we're going to talk about today is something called active standby. In some ways similar, but the key difference here is that we're sharing two different broadband connections. So in this example here, we've got two routers. Again, we've used in this case the example of 2860s. The master is connected to the DSL connection or broadband connection 1, and the slave is connected to DSL or broadband connection 2. Now, in this particular scenario here, it may well be that the main connection, main DSL connection, could be VDSL, for example, and the second connection could be a different form of connections. For example, it might be an ADSL connection. I suppose it could be a Virgin Media connection. You've got DSL on one and maybe Virgin on another. So because of that, there can be no synchronization to the two routers, because obviously the setup is going to be slightly different for both. But other than that, the principle remains pretty much the same. You've got the concept of a master that's active, and the concept of a slave that's on standby mode. So to put that into more sort of definitive description there, all the traffic goes through the master unit as a standard, and the slave router is there on standby. We get some sort of catastrophic failure occurring. So in this example, we may have the router having a problem or the line having a problem. And what happens in that situation is that all the traffic then gets routed through the slave in standby. So once again, you've mitigated here for a line and or hardware failure with no loss of service for all the users in the network. I think it's probably fair to say that the different levels of resilience I've talked about are applied in different ways depending on the type of organization. I think we can all see that there's a good get me out of trouble option for the WAN resilient solution. There's some that you've got to invest in for a line failover type scenario on load balancing. And obviously in a high availability mode, it's probably a kind of higher investment because you need to buy an extra router and potentially an extra line, and more complexity in terms of how you set the whole thing up. So you've got important, very important, and mission critical, I suppose, that you'd apply to these all. And in many organisations, we see that some sites have high availability. I can say this, high availability. Some have just line failover, and the less critical one maybe have that one resilient solution as well. So hopefully you've got a kind of solution there that meets all requirements and all different types of budget as well. So just to summarise the two different modes there, hot standby, configuration of the primary is synchronized with the second device. A single WAN connection is shared by both devices. The device with the primary role will have the established WAN connection with the secondary one kicking in as needed. On active standby, there's no configuration synchronization because they may be connected to different broadband connections. So different WAN connections clearly used by both. And both the prime and the secondary have the active WAN connection, but only one is used at any one time. So hopefully that explains the concept of hardware redundancy. So anyway, so far we've covered line resilience, what happens if the line fails, and we've now covered hardware redundancy in our high availability solution, what happens if a piece of kit fails. The final sort of piece to this jigsaw is traffic balancing and control. So kind of why is this important? And this is important for a whole bunch of reasons. The first one being that there is bandwidth sensitive traffic, and I suppose the classic might be voice over IP. So you can have a network working completely fine, everything's wonderful, but all of a sudden there's a high usage of data for whatever reason, and if you're not thinking cleverly about how you balance the traffic, the VoIP can be affected. But I think we all know there's fantastic IP PBXs out there and hosted VoIP solutions, but they all sound absolutely terrible if there's not enough bandwidth chucked at it. So traffic balancing control is very important for VoIP and other bandwidth sensitive applications. The other reason it might be important is that we do get intermittent line speed issues. Internet can be fast one day, it can be slow the next, fast the next, and you can get all sorts of different changes. If you do a speed test on your internet connection, it changes all the time. So one needs to be aware of that. The third thing is this whole concept of data usage and peaks of non-essential traffic. Quite interesting with this concept of kind of Wi-Fi now, that businesses will typically have the main connection that everybody uses, and if you're anything like me, you tend to be quite careful about how you use that. You don't want to send lots of unnecessary traffic on it, but when you're unclipped from that and you're on your mobile device, still in the office using the company's Wi-Fi network, it's kind of a bit of a free-for-all. I can start looking at YouTube and downloading stuff and doing goodness knows what. So in organisations that have got this combination of fixed connections through the local area network, and then this wonderful opportunity to use Wi-Fi in your spare time, that Wi-Fi traffic can have a massive effect on the rest of the data. So one needs to be available of that. And the final thing is really just leads on to what I said earlier on. If you've got a line failover situation taking place, and we're used to having an 80 meg service, and suddenly it's only a 20 meg service, some consideration has got to be given to all this traffic that was working fine on 80 megs. It's now being forced down a much slower 20 meg, the caught into the pint scenario. So this is where traffic balancing control, again, is extremely important for business continuity. So what I'm going to do in describing this, I'm going to use a ton of typical scenario. I've used a very simple one to make the point, but obviously hopefully you can make this more complex as needed. So here we've got a situation where it's a dual WAN network. So we've got WAN 1 and we've got WAN 2, and we've got both voice over IP, the sort of bandwidth sensitive traffic, combined with the data which isn't quite so bandwidth sensitive. And what we're going to show here is something called policy routing. So this is something that forces specific traffic down a specific WAN port for efficiency. Also, we can show how different policy routes can apply to different events. So you might want a policy for when things are normal, and you may want a different policy to kick in when suddenly you've got less bandwidth available. And we're going to show how we can use this in a kind of line failover mode, and we're going to see how we can, using policy routing, apply quality of service to make sure this works in the most effective way. Easier to sort of show on a picture than to describe, to be honest, and I'm going to attempt to do that now. So here we have an example, as I said earlier on, of kind of VoIP traffic and data traffic on the LAN, and this is going down WAN 2 and WAN 1. So hopefully this will kind of show now. You should be seeing any moment now. There's a kind of green dot that's going, that's basically representing the VoIP traffic, and all that VoIP traffic through the policy route is being forced down WAN 1, and all the data traffic through the policy route is being forced down WAN 2, and everything is working absolutely fine. So what we're going to kind of now show is that how we can use policy routes in a failover mode and invoke quality of service, if you like, for the first time across a single WAN port. So back to our example here, which I've just kind of shown you. In this example here, VoIP traffic was happily going down WAN 1, data traffic was happily going down WAN 2, and WAN 2 has failed. So in this example here, I'm going to introduce the concept of kind of quality of service. So we're all kind of familiar with traveling on an aeroplane and class of service. We've got kind of, Premier travel and different classes. And in this particular example here, the Premier mode of travel we're going to apply to VoIP. So the different modes are represented by these different silos here. We've got red going down to blue. So the red silo here is absolutely the highest priority. So this means that any type of data in this high priority will get the largest amount of bandwidth allocated to that particular type of traffic to give the best possible service, and the less important traffic will get various levels. In this particular example here, we're going to say that data traffic gets the lowest class of blue, voice traffic gets the highest class of red. Now obviously in a network, you can have all different types of traffic with different levels of priority, and using the system within the router, you can again apply different types of quality of service to different types of traffic, depending on how complex the environment is. But for the purpose of this, we're going to make it very, very simple. So VoIP is going to have the high class red, data is going to have the lowest class blue. And hopefully this will kind of work in the diagram I'm showing. So the voice traffic, denoted as green, goes through the router and is now become red. The data traffic, classified as grey, comes through the router as blue. And you can see that's all going through on the same link. So effectively, we've lost a connection. The total amount of bandwidth now is much smaller. All the VoIP traffic gets that high class applied to it. All the data traffic gets that lower class applied to it. And this now means that whilst it's a slower speed, and maybe it's not at optimum capability, you've still got your business running. The voice calls work really well. The mission critical data gets through very, very, very effectively, and the business can still operate. So this is a way in which, using quality of service and policy routing, you can have business continuity in the business, even when the worst thing kind of happens. So I'm going to just expand this a little bit further with this diagram here. Here we got voice and data, telephones and screens, all jumbled up on the local area network. It goes through the policy routing and quality of service on the router, and you can see there that voice traffic is segmented up here and data traffic is segmented down there. On this particular diagram, you've kind of divided it exactly into two, but it could be like 90% voice, 10% data, 60% voice, 40% data, and so on, depending on the environment. And unfortunately, not time to go through this in any great detail in this particular webinar today. Sorry, the heading seems to have just run off the page there a bit. On this, what we're basically saying here is that in an environment where you've got a very high speed primary connection, in this case VDSL, and a lower speed secondary connection, in this case ADSL, 80 meg up there, 20 meg down there. What the system intelligently does, using something called weighted load balancing, is it forces 4 times the amount of traffic down the high speed link and only 1 times the traffic down the lower one. So that means in a ratio of 4 to 1, because that's the ratio of the speed, traffic is balanced sensibly or appropriately using weighted load balancing down these 2 particular links. And in addition to that, you can apply appropriate quality of service to both those links as well. So actually quite a meaty subject, this, as I say, not time to go through it in great depth today, but hopefully that gives you an idea of the concept of how this can be used in balancing across 2 different lines at different speeds and making sure all the traffic is prioritized appropriately. So I'm now going to spend a little bit of time on the specific products that can help you achieve this business continuity. So the first one to talk about is the Viga 2860, which I've kind of touched on now. Great thing about this is that business class, packed with features. You can connect to just about every broadband connection there is available today. Primarily it's bought for VDSL and ADSL, but can also connect to 3G, 4G with the LTE product. It can connect to any Ethernet WAN service, as I've mentioned before, which could be satellite, could be Virgin Media, and obviously with this kind of wireless WAN option, you can potentially connect to another broadband connection controlled by a different wireless network. Fully MCT approved, very, very important that. You probably remember when VDSL first came out, BT mandated that you had to plug their OpenReach modem in order to connect to it. That router is no longer, that modem is no longer supplied as of March. So if you're connecting to a VDSL service, it really must be MCT approved, and we're delighted to have got through earlier this year. It has 3 gigabit LAN ports as standard. You can see them down there. So for many small businesses, that may mean you don't actually need to buy a switch. So that's quite a lot of power kind of plugged into it. And in addition to all the kind of 3G, 4G and the wireless, it's got this high availability feature line resilience feature built into it, and also quality of service as standard. So that all comes with the standard firmware, no additional licensing, no additional software firmware to buy. It all comes in the box as standard in the usual model. So really packed with features, and one that I'd point you all towards. The second one, I'm not going to really talk too much about this other than to say it's very similar to the 2860. It's called the Viga 2925. So this is black, but the other one was a kind of beigey colour. And the main difference really here is that instead of a VDSL, ADSL WAN port and an Ethernet port, it's got two Ethernet WAN ports as standard. So this is really used for Ethernet only type services such as Virgin Media or satellite or something similar to that. But in addition, other than that, it's pretty much got the same features as I've spoken about on the Viga 2860. The other two to introduce here is a product called the Viga 3220. The sort of redeeming feature about this one is that it's got 4 Ethernet WAN ports, which you can see down there. Now this is typically used where, for whatever reason, multiple broadband connections are required. This can just simply mean they've got a very high throughput requirement and want full VDSLs. This has got a kind of a 500 gigabits throughput, so very, very fast. That should be megabits, I think. 500 megabits, not 500 gigabits. Apologies for that. So that's 500 megabits. So it can be used when you want very, very high speed, or it could be used, for example, where you've got a very slow broadband in the area, maybe 2 or 3 megabit broadband. And so what you're going to do is kind of bring those all together in a kind of load balancing mode to make sure you can fulfill the needs of the business. So really good solution for that. The other one to introduce is the Viga 2952. This has basically got two Ethernet WAN connections, 500 megabits throughput, and typically used where high speed is required. So the great thing about the 2860, the 2925 and these two products is that they all share the same operating system. It's actually something called Dreos. So the look and the feel and setting up the config is virtually identical. So if you kind of know one, you sort of know the other one as well. So quite a nice, neat family, so a bunch of products that make up the family. So we've now really talked about pretty much what goes on when you're kind of locally connected to a network and what can you do about these physical connections. This actually neatly leads into kind of using Wi-Fi and network optimization. So I said earlier on that most businesses do tend to have the concept of a Wi-Fi network as well as a main business network. They'll use the Wi-Fi network for maybe employees that want to wander around and do stuff in lunch periods and so on. They also use it for visitors and guests, but often it's used as whatever I want to do outside of business, which can create this situation as I got down here. You've got kind of bandwidth hogs doing all sorts of things that are affecting high priority workers. But other things can affect business continuity on a Wi-Fi network, and we're going to talk about some of the things that Draytech do that can assist on that. So the first thing is, and we've all seen this, you open up your laptop, you look at all the Wi-Fi networks available. There's 20, 30, 40, 50, sometimes hundreds if you're in a very built up area. And all these different competing Wi-Fi networks can create interference, can create poor service and therefore affect business continuity. You've also got a whole plethora of devices that access the network, all the latest tablets and iPads and mobile phones and smartphones and so on, and you've got people wandering around using all different types and sizes that can be old and new. So you've got this massive proliferation of different devices to address, and you've got this loads of different Wi-Fi standards. I mean, you may well be familiar with the latest and greatest AC. There's also wireless N, dual band, wireless G, and a whole bunch more. So in terms of managing it and controlling it, a bit of a nightmare. Also, when people come into the network and use Wi-Fi, you may need to put in multiple access points to cover the different reaches of the building, and there's a need for this mobility for to come in, connect, and wander around without losing connection. And from a business point of view, it really does need some serious control, possibly controlling who's doing what and when, prioritizing certain users, using quality of service and so on and so forth. So looks like, hey, we'll just whack some Wi-Fi in, but actually when you put it in, you can end up with a whole bunch of issues to provide a network that has business continuity and is safe and secure. And of course, what you need is managed wireless from Dratec will address all these issues. So the first thing that a Dratec managed wireless solution will deliver, and this is some of the benefits here, is that you get the concept of one virtual network. So, one network that's got, guest SSID or company SSID, but actually delivered through lots and lots of different access points put at different strategic places within the business. So the idea is that there is a single virtual network, but it is delivered across multiple different access points that are all controlled. So that's kind of the first thing. The second thing here is the ability to balance traffic. And we've got the example here of maybe a conference center or a place where there's lots and lots of people. We've also got some very interesting case studies coming up. Any of you that went to Wimbledon this year may have been fortunate to go to the VIP hospitality place called the Gatsby Club. In this particular place, this was provided by Dratec Wi-Fi. We had to use load balancing extensively there because there were many hundreds of people in this particular club, and obviously you wanted to balance the traffic across all available access points. Also many other examples in the UK, one being the Cavern Club where the Beatles started, which have got this kind of system as well. So the basic idea is there's 100 people in a room, there's lots of access points available. You want to make sure that every one of those access points is used in the most effective way. You haven't got one access point taking up all the load, because that's what people log on to when they enter the building to start with, and everything else kind of not being used very effectively. So load balancing is a very effective way of giving business continuity. Other classic requirement is mobility. I want to log in as I enter the building, and then I'm going to move around onto maybe a second part of the building, onto a third, and onto a fourth, and I want to do that without losing connection. So mobility is an essential part of Dratec's business continuity managed wireless solution. The other area is this whole idea of protecting against congestion. Now, congestion is a major problem now. As I've already said to you, lots and lots of competing networks in a particular airspace, and also lots of congestion within the network as well. So the first thing that we can do to assist on that is we support something called dual band Wi-Fi. And this essentially means that the access points within the network will broadcast on the 2.4 and 5.8 gigahertz channel. This very simply put means that on the 5.8 gigahertz channel, it's a much higher frequency spectrum. It means there's much more sub-channels available, and it's not so badly affected by other local Wi-Fi networks in the area. So very simply put, if you're seeing lots and lots of SSIDs in the area, you probably want to be on this dual band. And basically, if you can see 3 access points, there is going to be some interference of some shape or form. If you've got 20, 30 or 50, there's going to be potentially quite a large amount of interference there. So that's a good reason, mate, why you may want to put in a solution that supports dual band, which indeed we do. The other thing that you can do within the network, there's 2 really interesting features here. One is called band steering. If you open up your standard Wi-Fi enabled device, like an iPhone, an iPad or something, it often has the capability of communicating using different standards. So the 2.4, the 5 or dual band. And so what we can do within the Dratec product set is effectively force the clients or the mobile devices to communicate down the less congested bandwidth. So for example, in this example here, you're basically saying if anybody's got the 5 gigahertz band, automatically force them down that route if it's possible. If it's not, defer to the 2.4. So again, this kind of means that every device can be forced to work at its most effective capability. That's called brand steering. The other feature is something called airtime fairness. I'm going to use an analogy here, which I just thought up this morning, which my technical people are going to cringe at, but I'm going to do it anyway. So basically, just imagine you're queuing up at an airport trying to get onto a plane, and there's always a family in front of you that takes forever and is extremely frustrated. So in any given queue of people, maybe there's 30 people, possibly 1 in 5 is one of these families that takes forever to check in. So instead of having 4 families in a row checking in and being incredibly slow, you can set it up so that you get a slow check-in family once every 5 people trying to check in. So it effectively means that, yes, you've got a slow family, but the 4 that can check in fast come in immediately afterwards. I hope that works. It kind of worked for me, but well, I guess only time will tell. So effectively on this, you've got in this example here, the 11N band, which is the effective way of communicating, and you've got the 11G band, which is a slower way of communicating. In other words, it takes a lot longer for the 11G user to do what they need to do than the 11N user. So what we're basically saying here is, instead of the 11G, then the 11N, the 11G, then the 11N, it does it in a fairer way where everyone gets the same amount of kind of check-in time or amount of airtime on the network, which means that all the users can be handled in a much more effective way. So the slower speed guys don't hog the bandwidth to the cost of the faster speed guys that can do much more. So I hope that analogy worked. It kind of worked for me, and I hope that kind of explains airtime fairness, which is a kind of key part of what we do. So to kind of wrap this up now, management and control is a very important part of this as well. If you've got 1 access point to kind of configure and manage, it's a bit of an issue. If you've got 20, it can be a major thing. So cleverly, within the routers that I've spoken about, the 2925, the 29, the 2860, and the other higher end products, within those products and within those interface, and again, kind of for free as part of the standard firmware, you can manage up to 20 access points on the 2860 and up to 30 access points on the 2952 and 3220. And what we basically mean by that is you can set one standard configuration once, and then you can proliferate that or provision that to all the access points simultaneously. And the really neat thing here is, when you set this thing up, you set the config up once, and when you plug in the access points will all automatically get their standard configuration downloaded. So in terms of kind of managing a network of lots of different access points, it's a really, really neat way of doing it. Lots of other things you can do. You can upgrade firmware. You can store the configuration. You can see what's going on the network. You can identify access points that are working, and it goes red if they're not. You can see rogue access points that can be seen within the bounds of the building but are not part of the network, and so on and so forth. Again, a big meaty subject in its own right. Not enough time to go through it in great depth today, but loads you can do through that management and control thing. So to summarize the managed wireless benefits, you can put lots of access points within a building, and it forms one virtual Wi-Fi network that, as far as the users are concerned, they just see it as one. You do some clever stuff on balancing traffic to ensure every access point is used to its maximum capability. You can use this mobility feature to ensure people can move around without losing connection. You've got all these congestion contingencies to ensure that other users or other networks don't affect the good use of the network. And you've got this clever stuff in band steering and airtime fairness to make sure it really is fine-tuned to optimum. If you combine all this with the policy routing and the quality of service that's I've spoken about on the routers, you can really set up a network that really works brilliantly for all the different types of users. And when a problem occurs, you can apply all these contingency facilities and apply quality of service to ensure that network absolutely sings to its optimum capability, even when you get a failure, to deliver that business continuity that's so important in today's type of network. So just a quick whistle stop through tour through the different products. So in terms of our access points, the basic model is the AP810. You can see what it looks like. Neatly, it's got a kind of 4-port switch on the back, which is quite neat for some organisations. You can use this as in a managed environment in conjunction with managed wireless through one of the routers. It can also operate in standalone mode as well, actually, so you don't necessarily need a user to manage it. It's quite happy on its own. You've got the switch, it supports 2 LANs. You can power it through standard mains plug or through power over Ethernet. Different SIDs for kind of guest and business network, however you want to do it. Lots of control facilities, all that central management, and a whole bunch of other interesting things you can do, like a site surveyor, so you can figure out where access points do. And a rather interesting niche feature here is you can plug in a thermometer dongle, and that enables you centrally to monitor the temperature of the surrounding particular room. It's quite useful for certain environments, that. So that's the 810. The one up from that is the 902C. Basically does everything the 810C does, with the exception of this now supports wireless AC and dual band. So for all those sort of congested areas where that's a concern, that might be quite important. The 4-point switch is gigabit, and there's a few enhanced management features as well, which I haven't got time to go through today, but it's probably more of the standard product that we sell in most environments. Another interesting one is the AP910C. This is very similar to the 902, but as you can see, it's got a different form factor. It's in what we call smoke alarm style, so you can attach it to the ceiling. It's a little bit more covert, so away from sort of, prime malicious people want to pull areas out and pull cables out. Really neat product there. Supports all the standard wireless, all the wireless standards. Is ceiling mounted, as you can see, with a kind of ceiling mounted bracket. Literally just screws on and operates in all the different modes there. And in fact, we often find in typical environments that organisations might use the 902 for the office and might put the 910C maybe in an area where they might see visitors. It's good for a kind of counter or something like that. Again, hot off the press, this was reviewed by PC Pro magazine in August and was given a PC Pro recommended product for businesses and home users. So highly acclaimed, and really completes the picture in terms of managed wireless for the company. So I have really gone through this before. The 2925 and the 2860 will manage up to 20 access points. The 3220 and the 2952 will manage up to 30 access points. And in fact, again, not time to go through it today, we have a central management system called ACS, which can potentially manage up to thousands of access points. So if you've got a situation like that, please do contact us and we can show you how you can provide central cloud management for those types of environments. And that's just a view of the central controller and the products there. Okay, so I'm going to, I notice we've got 7 minutes to go towards the end of the webinar now, so hopefully I've pretty much kept to time there. I'm just going to wrap up by talking about some of the supporting materials that support this webinar. I'd also say that I will be emailing everybody afterwards to show you where all the notes are, show you where the webinar can be downloaded, because again, this is actually been recorded, so you can download it and take a look at it at your leisure. There's also a load of resources that I'm going to kind of introduce to you now. So we've put together a kind of PDF style mini guide for both the business continuity solution set and the managed wireless solution set. We'll give you details about how you can download that. The website is incredibly comprehensive in terms of the information you've got available there. If you want to know specifically how to set up routers in different modes, we've got a host of information there. If you go on to dratec.co.uk, go on to support, you can see here there's a drop down called product knowledge base. You do need to register for this, by the way, so you will need to have a product to hand and enter a serial number. But once you've done that and entered once, you've got full access to the knowledge base. And here you can enter a particular product, so Viga 2860, and it will show you all the FAQs against that. Or it might be quality of service or load balancing or a particular theme, and again, you can search for that. So really, really full, comprehensive list of FAQs. These are not just a simple Q&A. These are really comprehensive articles showing you specifically how to set something up. So I'd encourage you to kind of use that. We also, we're introducing these more and more. We've got some what we call our technology guides. So if you go to, again, dratec.co.uk and go on to information and use the drop down our technology, there's a host of really, really good stuff here. In fact, a lot of what I've spoken of today is kind of supported in these sections. In this particular example here, you see we focused on load balancing, and you've got and this is quite a long section here. You can see there's a description of it, and actually down below there's probably 3 or 4 equivalent A4 pages of information there. But you can see other stuff here: policy-based routing, web content filtering, wireless LAN management, VLANs, IPv6, and a whole bunch of other stuff there. So please do feel free to have a look around that, and I'm sure you'll find a load of really good stuff to support everything I've said today and hopefully help you in your business. So I've now spoken, I think, for 55 minutes, and we're just nearing the end of the webinar. So I hope that was a nice view of kind of what we do. There's a lot of technical stuff that backs this up, and I kind of hope you appreciate there's not time to cover every single nook and cranny and every single finer detailed technical setup that we do on that, but I hope that gives you a good understanding of why business continuity is important, and the types of ways that you can either deliver or you can install on your network to ensure your business keeps up and running, even if the worst happens on the network or within the broadband setup. So I think what I'd now like to do is kind of open the floor up to any questions. I know, Alex, you've been listening intently and maybe also picking up some questions that have come along. To get the ball rolling, do you want to just comment on any common themes of questions? So maybe we could address those to the full audience.
Hi, Julian. Thanks very much. Yes, you've encouraged through all the different slides. You've got lots of questions that have come in during the webinar. So a lot of them we've been answering over the text to people as we go, but there have been quite a few that have been repeated questions, so it might be good for us to cover some of those. Yeah,
maybe do a top 3 or something like that. Great.
Yeah. So a common question is about high availability on the 2860. So people are interested in knowing when that's there because they've noticed that it's not in the formal release right now. So a quick answer on that is that it's in a beta, it's 384. So if anyone contacts our support, we'd be happy to provide that to them. And 384 is going to be released relatively soon. It should be before the end of the year that we'll have that as released, I believe. Currently, I mean, it depends on testing schedules, but that's coming very soon. And if anyone wants to have a go with it, they just need to contact support, and we can provide the beta firmware to them.
Could I just interject there as well, Alex? I believe that we have production firmware for the 2925 and the other products. Have I got that right?
That's right. Yes.
Yeah,
yes.
okay,
it's already
cool.
in those. It's just the 2860 is not released yet, but it's
sure.
Very soon.
I think maybe also worth adding that when we say beta code, this is in a very advanced state. It's not like we're testing it out to see if it works. We're well beyond that stage. This is really, really very, very close to final release. I know we do have some organisations using this in a production environment, so it's in a good state of play, I suppose is what I'm saying.
Yeah, I guess it's probably more correct for me to call it a release candidate rather than a beta. And yes, it's been, there's a lot of testing that's already gone on on that specific firmware version. That's right.
Okay.
Another question is about setup guides for HA. That a lot of people have been interested in the knowing more about the setup. There's 3 articles that hopefully people may have noticed I put into the chat. If they look at the chat, they may see those links there. But Julian, I believe you're going to be sending a follow-up email to people, so you'll be able to include some of the setup guide links to some of the items you've touched on.
What I'll do, I'll sort of include the key Q&As as well. So if you're wondering about where do I go on the website to get stuff, don't worry. I will send you a comprehensive email that has all those links. So there'll be plenty of reference material coming through afterwards.
Yeah, there's about 5 or 6 follow-up questions that are all very similar, but just on some of the other topics. So we'll just include all of those in your emails. People have the links on the features. Another question was about the AP features. So things like band steering. There's a question about whether that's in the 2860 wireless routers and the 2925 wireless.
Gotcha.
Which I can answer. The feature is coming to a beta firmware. It's in a beta firmware on the 2860. So you'll find that airtime fairness will be in the 2860 firmware in the future. So that's something that's coming. Similarly with some of the other functions, if you see the IPs, then if we can, we do like adding them to the 2860N standalone as well. But as it stands currently, the airtime fairness isn't in the formal release, but it's coming quite soon on the 2860.
Okay, any others of note before we throw it open to the floor?
Yes, there was several questions. Some things about the LTE setup. People have been asking about if you can get a public IP for the LTE to help with opening services up if you're failing over, and that's something that is best discussing with the mobile providers. It might be that some business ones might be able to offer that specifically as a service because it does depend a lot on the provider. So it's something we'd recommend checking with them if you're looking to try and get a public IP where you can do NATing. What we'd recommend is looking at the policy route functionality we've got on the router, because that really helps with load balancing and controlling what fails over where, and in some cases you can route traffic through a VPN if your WAN goes down. So something we found very effective is when you route over to LTE, you can have the VPN tunnel that only comes up if the LTE comes up, and then you can route your traffic through that VPN tunnel to then get around NAT issues that you may have. So have a look at the policy route articles. They'll be included in the email that Julian sends out, because that can really help with getting over some routing challenges that occur when you're doing load balancing and failover.
Okay, Alex.
And there was actually one other question that's quite, I think, relevant on the HA side of things, to do with the IP address. The question about if you've got a gateway, how many different IPs are there that are on the network that the clients have to be set with? And the answer is quite straightforward. There's a single virtual IP that the PCs, the clients, need to be set with, and the master and slave take care of the handover of who uses that IP address. So it's completely seamless from the point of view of the client. The client doesn't know really that the master or slave has switched over. It wouldn't notice. So there's no configuration you need to do, especially on the PCs. They can just be set with DHCP or have a static IP. They just have to have their gateway set to be equal to the virtual IP that both the master and slave share ownership of.
Okay, Alex, thanks very much for that. What I think I'll say now, we've now spoken for about an hour. I think it's about 2 minutes past 11. What we'll do is we'll open it up to the floor if anybody wants to ask a live question. And what I'll do, I'll promise you faithfully that we will formally close the webinar at 10 past 11. So that maybe just overrun by another 10 minutes, but hopefully it's useful questions we're getting, and people appreciate the replies we're giving. So do you want to just see if anybody wants to ask a question? Obviously you can just click your raise your hand and you're welcome to do so. I've got one down here actually. I can see a Brian Martin. Alex, can you see Brian? So what I'm going to do, I'm going to unmute Brian, and we'll see through the wonders of technology whether we can have a live conversation. Brian, can you hear me?
I can hear you. Can you hear me?
I can hear you fine. It worked.
Good. I must admit this issue of failover is becoming quite important to several of my clients, and I've been testing out the 4G options, and so far the tests are looking good. But I have noticed one thing which concerns me is what about incoming VPNs? Because the failover, of course, then isn't the remote VPN coming in isn't going to be able to use the same IP or dynamic DNS address.
So thanks for the question, Brian. Alex, just before we start, I'm aware that we're a little bit time constrained here, so if you can give a concise answer, and if we need to follow it up in more detail with Brian, perhaps we should do afterwards, because I suspect that might be a long response, but I don't know. But anyway, over to you, Alex.
Yes, I think it's something that would be worthwhile us discussing directly, separately, to go into in detail. There are methods you can use. One example is trying to make it so it's dial out, because then that gives you a little bit more flexibility, and you can set some VPNs so that in their profiles that they don't require a specific IP address for the other party to be coming from, using a global pre-shared key. So there are some different ways of doing the configuration, but I think it's something that's really needs to be covered. If you contact support and discuss it, they'll be able to go into it in detail, because it can get very, very complicated, and there's lots of different scenarios that you might try to be catered for, so that there's different approaches. But it's something that yeah.
Just an extra on that one is a couple of the clients I've been sort of suggesting this to and actually showing them in a demonstration. The issue is that they're keen to keep their ability to look at the cameras in, remotely, and that would obviously need to come in through a different VPN.
Yeah, what you can do in some cases is have a VPN that only comes up if the LTE comes up, and then use that one as an alternative instead of your normal methods. And you can use policy route to route things down if a WAN fails, to route something through a VPN tunnel rather than across the normal WAN connection that it uses. So the policy route, I think, is going to be something you'll get a lot of success out of with different scenarios.
Okay.
I think
Sorry, go
one
on.
interesting point. The 4G quite often gives a much better upload speed, and therefore anybody wanting to send data they can get much faster than the ADSL upload speed offers.
Yeah, and things like policy route and load balancing rules can help with that if you've got some specific IPs that you want to use a specific connection because you know it's got higher up speed. So that can be quite helpful for that sort of scenario.
Okay, so thank you very much for your question. Yeah, thank you for your question, Brian.
That's the VPN issue. Thank you.
Okay, Brian, thanks for your question. Yeah, please do contact our support, and I'm sure they'll be able to help you. I think I've got one other question here. I can see there's a Dave Toomey. So no, actually, for some reason I can't unmute Dave Toomey. This is another one down here. Yeah, I've got a John Eskdale. So, John, can you hear me?
Yeah, I can hear you fine. Yes, thank you.
Hi, John. How you doing?
Hi, thank you. Yeah, just a quick one. I mean, you're suggesting putting devices onto the 5G to reduce the network congestion instead of the 2.4, which is good. But I mean, I find that if two devices connect to the same access point, AP900, then if they're on different bands and they can't communicate with each other.
Okay, Alex, do you want to take that one?
There's no technical reason that I can think of for that. I think it's probably worth us discussing it with support, and then we could look at that specific case to see if there's anything that needs looked into in the configuration. But they should be able to communicate with each other, as far as I'm aware.
Well,
but it's
as a
discussing
very
with
quick
support.
example, on very important things like a coffee machine, which is Wi-Fi connected, and the mobile phone. If they're both on the 2.4G, and they connect to the same access point, then they will work. If the phone's connected on the 5G and it's connected to the same access point, it won't work. But if I connect to a 5G on a different access point, it does work.
I mean, I've done that sort of scenario and had it working. So I think it's probably worth us taking a look at it. If you contact support, we can look at specifically to see if there's anything that's up, and then take it from there. Really. So it's something like that should be working.
So John, please do contact support. You've got all my details. If you've got any difficulties, just please don't hesitate to contact me, and we'll try and sort things out. But it sounds like it should work. We're not quite sure why it doesn't, and we'll do our best to help you.
Yeah, it will. I mean, it just seems. I mean, it's not just that one device. You know, things like if you're trying to cast to a Chromecast or something like that, if they're on the same access point but on different bands, they don't work.
Okay, we'll have to take it offline, I'm afraid. I don't think we can nail it today, but
Okay.
But thanks for your question, John. Please do contact me afterwards.
Okay, thank you.
Thanks, John. I think we'll just take one more. I've got a.
Actually, Julian, in the meantime,
Yeah.
There's another question that I just wanted us to deal with. There's been a lot of interest in technical webinars, so I wondered if you could cover what we've got available and what we've got upcoming.
Yeah, sure. So again, we do have a number of technical webinars available that we have recorded previously, and what I'll do, I'll send you information of where you can get that information. There's also quite a lot of video help as well, and again, a lot of these kind of Q&A type articles that help you configure things in a very specific way. So there's actually a host of stuff already recorded. Some of it tends to be more positioning, some of it tends to be more technical, and what I'll do, I'll make sure I point you towards the appropriate materials so you can understand exactly how to set these things up. Okay, so I think I'll take one more question, Alex, and I think we'll call it a wrap. So this just 1 second. I think that's probably it, actually. I can't find anybody else. So Yeah. Okay. So so I think we'll wrap up now. So it's 9 minutes past. So I just say thank you very much for attending today. Really hope you found that useful, and it's given you an insight into the sort of things you can do with Draytech to deliver business continuity. I'll follow it up with an email with where you get all the supporting material from and where all the guides are. And we hope to see you again on another webinar coming sometime soon. So thank you very much. Have a great day, and we'll be speaking to you shortly. Bye now.